know you people are having a great time at home. Uh, this is another day on online class. Before we start this class today, I will try to appreciate God for what He has been doing for us. Giving us life is a very important thing. I know you are having a good time at home. Okay? Today we'll be looking at number system. You know, we have not completed number system, so that we still need to convert from one base to another base. So today's class, we are going to look at conversion from a given base to base 10. Conversion from a given base to base 10. What do I mean by conversion of a given base to base 10? It can be base 2. Base 2, which we say that it is binary. Base 2, which is regarded as binary. It can be base 8, which we say is altered. So we are going to look at in this class how to convert from a given base, which can be base 2 or base 8 to base 10. And I remember, don't forget, in the last class I told you that base 10 can also be called what? Denary. So we are going to look how to do that. So for you to convert from a given base to base 10, there is something that is very important you have to do. One, you can do that by what we call what? Expansion. It is done by the method of what? Expansion. And this method of expansion implies multiplication. You expand it by what? Multiplication. Now the power of the old base, which is the given base that was given, which is called the old base, you use it to multiply it, the power, and raise it up to the power. Okay, let us try this example and see how it's going to look like. Now, assuming they ask you to convert 11011 base 2 to denary, which is base 10. How are you going to apply that? Solution. To do this now, you will use this to multiply that particular old base, which is base 2, and raise it to the power, starting from 0 to the last power. Now, to do this, we are going to start from here. 1 times 2. This 2 is the old base, plus this one again. 1 times 2. The next thing here, we have 0 here, plus 0 times 2. The next one we have here is 1, plus 1 times 2. The next thing we have here is plus 1 times 2. Now, we have done expansion. This thing that we achieve here is what we call what? Expansion, by multiplying the old base, which is the given base. Now, the next thing we have to do for us to take this particular base 2, which is in binary, to base 10, is we have already expanded. The next thing we do is to take their powers. Now, for us to take their power, we will start from 0. We have a criteria that we say that n is equal to 0, 1, 2 till infinity. We can apply that here. So we start from here, 0, we have 1, we have 2, here will give us 3, and here will give us 4. Now we are going to, in mathematics, we use the word factor out more. So to do this now, 2 raised to the power 4, what is 2 raised to the power 4 going to give us? 2 raised to the power 4 is going to give us 2 times 2 times 2 times 2. Now 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is going to give us 16. So we are going to have 1 times 16. This means that when we raise 2 raised to the power 4, we had 16. So 2 raised to the power 3, what is going to give us is something as saying 2 raised to the power 3 is equal to 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is going to give us 8. We are going to have 1 times 8. Now we are having plus 0. 2 raised to the power 4 is going to give us, we are going to have 4, because 2 times 2 is 4. But 4 times 2 is going to give us what? 0. So here is already what? We regard here as already what? 0. Now we say plus. The next one we have is 2 raised to the power 1. And anything raised to the power 1 in mathematics, we say it's still 17. So we are going to have 2 here, plus 0 raised to the power 2 is equal to 1. According to the law of indices, we are going to have 1 there. So here is going to give us 1. So we are going to find out. If we go down, 1 times 16 will give us 16, plus 1 times 8 is 8. We have plus 0 plus 2 plus 1. This and this is going to give us, here and here will give us 24. 16 plus 8. 16 plus 8, sorry, here is 8 because 1 times 8 is 8. So 16 plus 8 will give us 24. Now this and this will give us 2, and 2 plus 1 will give us 3. And if we add this, we are going to get 27 base 10. So this, therefore, this implies that 11011 base 2 will give us 27 base 10. Okay, let me prove this. If I divide this by 2, I'm still going to get this. Let's do it now and see. Let's do it. You know, we are going to divide this. Let me show you. If I want to prove this now, if we are going to get the same thing, I have 27 from the last class. What we did from the last class, we have 27 divided by 2. Let's see if we are going to still get this. You know that this thing is in base 10. We want to send it back to base 2. It was in base 2. We send it back to base 10 and we have 27. So if we still send it back from base 10 to 2, we should get the same thing. Now we are going to have this. Don't forget, remember in the last class we have to apply our remainder. Now to prove this, 2 divided by this is going to, we are going to have 12. We are going to have 12 here. Okay, what 2 divided by 27 you should have, it's not 12, it should be 13 here. Should be 13 there, sorry. Should be 13 there. So here will be, because 2 times 13 should give us 26. Yes, should give us 20. So we have 13 here, remainder 1. So 2 here, when we divide this, we are going to have 6 remainder 1, because 6 times 2 is 12. 2 here, we're going to give us 3 remainder 0. 2 here is going to give us 1 remainder 1. 2 into 1, here 0 remainder 1. Now if you take this thing by up, we're going to have 1 1 0 1 1. This is base 2. So when we converted 27 base 10, we had 1 1 0 1 1 2. Don't forget, when we converted this again, look at what we have. So this and this is correct. So this is how to convert from a given base to base 10. So to do this, you do it by expansion, by multiplication, by the old base which is being given to you. I believe you have understand this class, and I believe you should ask more questions. God bless you. Thank you.